Hello everyone. Here we will evaluate the Christoffel symbol of both kind for the spaces for the space where Gij is equal to 0 if I not equals to j. First of all, we will discuss what is Gij. Gij is known as fundamental tensor or a fundamental metric. Suppose we have a n-dimensional space with the 2 points having the coordinates xi and xi plus dxi, then the distance between them is given like this. Here, this one is called the metric and Gij is known as the metric tensor. If we restrict ourselves in the Euclidean space, then I, j may varies from 1, 2 and 3. Varies from 1 to 3. So, if we put I is equal to 1 here and j is equal to 1, I is fixed for this row and j is equal to 2, I is fixed and now j is equal to 3, like this. This is for I barabar 1. Now we have to write for I is equal to 2, again j is equal to 1, I is fixed 2 here and we will vary j. And again in the third row, I is equal to 3 and j is equal to 1. Then like this we can write dx3 and dx3. Now if we have a metric in the Euclidean space like this, ds square is equal to, suppose dx square plus dy square plus function x, y and z and dz square. Then what is g11 and what is g22? And what about dx square? Here we have mentioned it is dx1 and dx1. Let us suppose x is equal to x1, y is equal to x2 and z is equal to x3. Then this can be written as dx1 and dx1, dx2 and dx2 and function which is the function of x, y, z and dx3 and dx3. Now if we compare these two, we will find g11 is equal to 1, g22 is equal to 1 and g33 is equal to 1. And all the other g's are 0 like g12. So here dx1 and dx1, so this one is the dx1 and dx1 when we compare g11 is equal to 1, but there does not exist any term which have dx1 and dx2, therefore we can say that g12 is equal to 0. Similarly, all the other g13, g21, etc. are all 0, so we can say that gij is equal to 1 if I is equal to j, or Gij is equal to 0 if I not equals to j. So this is the explanation of this term which is given in the question that Gij barabar 0 if I not equals to j. So this is the basic requirement in all our questions or in all evolution of the Christoffel symbol, that this condition must be satisfied here. Okay, Gij is equal to 0 if I not equals to j. Now we have to evaluate by using this equation 1 all the Christoffel symbols of first kind. Now here 4 cases arise. Case number 1, if I barabar j barabar k. Then in the equation 1, just put all these 3 just equal to each other. We find half del g I over del xi plus, if all 3 are equal, then these 2 will be cancelled and I will be equal to del g I over del xi. It is not only I, it may be j or j. It is equal to half del g j over del xj. in numerical problem here, in numerical problem there will be no I, no j, it will be 1, 1, 1, it will be 2, 2, 2, it will be 3, 3, 3, like this. So there is no meaning for I, j or k there. As we all know, in the Einstein summation convention, we may replace I by j, or j by k, or k by a, or a by b, like this. Now here comes the case second. Here we can take I is equal to k, which is not equals to j, or we may write I barabar j not equals to k. So that will be the case third. So now I is equal to j and not equals to k. Now by 1, again in equation 1, we will write I and k are equal here. So I, j, comma I. K is equal to I, but not equals to j. So therefore we have I, j, I. Then in equation 1, just substitute k is equal to I. Everywhere, whenever, wherever you find k, just replace it by I. And we will get like this. I have to write it down here. Half del g the first one is jk, so it will become ji over del xi plus del gik. The second one is, so it becomes I over del xj. The last one is del gij over del xk. So, but k is equal to I. In the first one is I is also here. So what we find? We find ji, and this one ii and that one. But we know that gij is equal to ji. Because G is a fundamental tensor, it is a covariant tensor, and it is also symmetric in I and J. So therefore Gij is equal to Ji. Therefore the first and the last term will be cancelled out, and we will only get half del Gii over del Xj. It is very important. Ij, comma I. Just you have to remember it. And also remember this one. If here like this A, B and A, then we have half del AA over del XB, which is repeated. It will be in the suffix of J, and which is non-repeated term, that will be in the denominator. So this is the case 2. So, and you have to remember it. Ij is equal to half del Gii over del Xj, or A, B, or whatever it may be. It may be K, I and K. So this will be half del G K K over del Xi. So this is the case second. Now here we come the case third. Where we may take I barabar J, which is not equals to K. So I and J are equal here, but it is not equal to K. So in the first equation, which was the definition of the Christoffel symbol of first kind, I, J, comma K, here we have to put J is equal to I, then we will get IIK. Then in the expression, whenever you find J, just substitute I there. So we will get del J. So in the equation 1, we have del Xi, then del Xj, then del Xk. I said del Xj, but we put J is equal to I here. If I is here, then there will be J and K. So for J, we will write I and K will be there. If J is here, then we have del J, I and K. So J ki jagah, for the J we have write I, and here we will write I and K. And in the last, if K is here, then we have del I and J. But J is I here, so we will write I. These two will be cancelled out. Not in the third case, they will be cancelled out. They will be cancelled out here. And if they are not cancelled out here, here we have given the reason that they are symmetric. That was quite accurate reason. But in this question, it is also given Gij is equal to 0 when I not equals to j. By this reason, these are also equal to 0. But here they are not cancel out. So we can say that Gij is equal to 0 since I is not equals to k here. So therefore, we will get minus half del Gii over del xk. This is the more accurate reason here also in the case second that Gij is equal to 0 when I not equal to j. Just remember. Now here is the case fourth where I not equals to j and not equals to k. Case 4. When I not equals to j and it is not equals to k, then by 1 I, j and k, what do you think? It will be del xi, del xj, and this is just by the definition. I have done nothing here. If I is here, then I will write jk. If j is here, I will write I and k. If k is here, I will write I and j. What will be its value? Okay, its value, just say that its value will be 0 since Gij is 0 if I not equals to j. Here all these three indices are not equal to each other, therefore we can say that this one is equal to 0. So in the last we have 3 cases. The first one was 4 cases. I is equal to half del Gii over del xi. In the second one, Ij comma I, so half del Gii over del xj. In the third one, I comma k, which is equal to minus half del Gii over del xk. And in the last one, where all the indices are not equal to each other, ijk, which is equal to 0. Remember them. Now here comes the second one, which is the Christoffel symbol of second kind. It will be discussed in the second video. So that's all for this one.